Hello students, this is Anjana from Computer Science Department. In this class we are going to discuss about hash functions and its applications, and we are having another topic called requirements and security. Okay. See, this is something related about the cryptographic hash functions. So basically a hash function is, why you are going for the hash function means, a hash function is used to convert a large size input message into a fixed size hash code. We can say it one as a h of m. We are denoting that hash code as a h of m. Why you are using a hash function? It is used to convert, if you, whatever it is a large size input of message m, so we are converting that large size m into the fixed size. So if you are facing the profile, you are sending some message. If it is a large message, at that time if you are going to face some type of problems, by using this hash function we are going to convert the large size into some fixed size. So we can say that we can denote that code by using a code called h of m. Okay, here the hash value h is generated by a function h of the form h, small h is equal to h of m. So here m is the original message, comma h of m is the fixed size of the hash value. See, here the letter m denotes the original message, m is the original message, and h of m is the hash code that we have generated after generating that fixed message, after generating that large message into the fixed message. So here whatever the source that we are taking, that source appends means what, that source is adding some hash code there. By whenever it is adding some hash code to the original message for the authentication, here we are going to check that particular message. So at the receiver side also, whenever a sender is sending some particular type of message, at that receiver, whenever the receiver receives that fixed message, at the receiver also, after receiving the fixed message, he has to convert that fixed message into the original message. So he has to compute the hash code on the receiver side also. We can say that message also m for the authentication check. So here the new hash code is compared with the received hash function h of m. So whatever the new hash code that is generated, that is compared with the hash function h of m. We have already said about the hash function. The hash function is nothing but it is used to convert the large size input message into a fixed size. So if you have observed this, if you have observed this image, so this is a message or some block of data. So we can say it is having some L bits. We are in this computer language, we have to convert this data into bits, no? So this is some size of so this is some block of data having the size of L bits. So for this block of data, we are going to implement the hash function there. This is the hash function. From after applying this hash function, we are getting the hash value h of fixed length. So this is a block diagram for the cryptographic hash function. So this is how we are going to generate. This is a simple block diagram. If you are going to take the message or data block of data of some length L bits, so this is the hash function that we are going to generate here. After applying the hash function to that particular message, this is the fixed length hash message that we are going to get here. Okay. Next one, suppose this is the large amount. This is how we are going to generate the large amount of data. See, this is the large message. We have to, by using the hash function, we are going to convert this large message into the fixed length. Okay. See here, this is message m, and this is h means hash function that we are going to apply here, and this is the converted message of fixed length. Okay. Here we are describing this thing, h is equal to h of m. H is the hash function that we are going to apply, where m is the message, large message that we are going to apply at the receiver side, sorry, sender side, where m is the input message of arbitrary length, some length. H is the hash function, and small h is the fixed length output. See, small h is the, whenever you are going to apply this hash function on this h is the fixed length output. Okay. See, these are the some of the applications of the hash function. So this is the message authentication is the one of the applications. So now let us see what is a message authentication. Message authentication is a mechanism or service used to verify the integrity of the message. See, whatever the message it is, suppose a message is having some particular amount of bit of data, so it is generally used to use it to service. Suppose having some bit of data, if you want to verify that particular amount of bit of data, for that purpose we can use this message authentication process. So this is a at the message authentication process we are going to use the cryptographic hash function. Okay, see, the message authentication is going to give the assurance that data, whatever the data that is received exactly as a sent. Suppose if you are containing no modification, if you are not doing any modification or any insertion or any deletion or any okay, whatever the message that has sent at the sender side also, that only he has to get at the receiver side. We should not modify that data, we should not insert anything on the data, or we should not delete anything on the data, and we should not reuse that data also. We are having this multiple cases, so there is a requirement that the authentication mechanism ensures that we can show that the identity sender is valid. Okay, we have to say that the sender is a valid person. When a hash function is used to provide the message authentication, the hash function value is often referred to as a message to digest. See, here we can say that by this we can say that uh, it is not a simply a mechanism we are going to use, but this is a major function that we are going to apply at the time of the message authentication. Why? Because in this mechanism, whatever the service that we are using is, it is used to verify the integrity of a message. So the message authentication assures that the data received, whatever the data received exactly as sent, that is, it does not contain any modification or insertion or deletion. In many cases, there is a requirement that the authentication mechanism assures that it is going to give some identity such that it is going to ensure that the purported identity of the sender is a valid. So when hash function is used to provide the message authentication, the hash function value is referred as a message to digest. See, we can see, if you have observed these multiple ways, you can came to an you can get an understanding that how we are going to send this hash code to a receiver. See, a variety of ways in which the hash code can be generated to provide the message authentication. See, to provide a message authentication, how many types of hash codes that we are going to generate here? Now look at this. This is a source one. This is a destination one. This is a message that we are going to get here. Message that we are sending here. This is a hash function that we are going to apply here. This is the message authentication encryption. For that message also we have to provide some encryption. No, why you have to provide the encryption? uh, to secure our data. So this is the encrypted key, and this is the hash function that we are going to apply at the source. Source means the sender, the place where the sender is sending. Destination means the place where the receiver is receiving. Okay, here the source is sending the data. After that sending the data, we are going to apply the hash function. For that hash function we are going to perform the encryption. Here both by encrypting and applying the hash function, we are sending it to destination. Whenever you are sending it to destination, again you have to do it for the you have to perform hash function to that particular message. Why? Because it is not a original message. So after applying that hash function, at the destination side, the receiver will receive the original message. So the message that we are going to concatenate, the hash code is encrypted by using the symmetric encryption, because only A and B share the secret key. Okay, what are the secret key that have generated, that should be shared by both only A and B. Why? Because A is a sender and B is a receiver. So between these two persons itself, they have to share the data. So whenever the encryption is a symmetric encryption, because only A and B share the secret key, the message must have to come from A and has not been altered. So whatever the hash code that we are going to provide, here the structure or redundancy required to achieve the authentication. So whatever the structure or redundancy is required to achieve the authentication. So because the encryption is applied to entire message, we have to apply the encryption also. In the whenever I am giving explanation to this figure, I have already said to you that we have to apply the encryption. For that, why we have to apply encryption, we have already know that to provide the security for our data. So the hash code whatever the hash code that we are going to apply, and the hash code that provides the structure or redundancy required to achieve the authentication. Why because we have already applied an encryption to the entire message plus hash code. Confidentiality is also provided. See, this is how we are going to this is one way that how we are going to send the message of so much length of a message to a fixed. We have converted this large message into a fixed length message. After converting that large message into the fixed length message, we have to provide encryption key for that. Why we are going to provide encryption is to provide the security, and for after it is sending to the destination. After sending to the destination, again we have to apply hash function on that message to reduce that fixed length into the original length message. Why? Because the receiver has to receive that entire message. No, this is one of the way in which the hash code is used to provide the message authentication. Now go for the next way. We are having the multiple ways also. Suppose this is again if, immediately after applying the hash function, immediately we can apply the encryption key also. After that we are generating this message. By that we can send this message. At this stage we are going to again we have to decrypt that one, and again we have to perform the hash function on that message. This is the code that we are going to get at the destination side. So only the hash function that is encrypted using the symmetric encryption, this reduces the processing burden for those applications that do not require any confidentiality. So if you have observed this message B, because this is the message and this is the source code. So after that we are going to apply the hash function here. After that we are sending the message, and again for that message we are going to, before comparing that message, we are going to apply the hash function there. After that applying the hash function here, this is a source message. After that we are here, nothing encryption is performed here, just applying the source function, and here we are going to compare that particular kind of data. So this is one example. See, we are having the multiple ways to find to send that particular data, but whatever the way that we are choosing, but that is not nothing matter the way you are choosing. Whatever the efficient and effective way, we have to choose how we can send the data within a short time and without any delay, and the sender has to receive the data without any delay. Okay, these are the two factors that we have to keep it on mind. Okay, next one, it is possible to use the hash function but no encryption for the message authentication. The technique assumes that the two communicating parties share the common secret value. So A computes the hash value over the concatenation of and appends the resulting hash value to the to B, because it can recompute the hash value to verify. So because the secret value itself is not sent, an opponent cannot modify an incorrupted message. So it cannot generate a false message. See, here in this particular case, after performing the computation of a hash value, if we are going to perform the concatenation, or concatenation means adding or appending the resulting to the hash value, here this particular example, here the receiver B has to process it can it at this particular At this particular situation, what it has doing is here the B has to the B has to recompute the hash function, and it has to verify. Because why? Because it has to verify, it is having some secret value itself and it is not sent. An opponent cannot modify an encrypted message and cannot generate a false message. So this is one of the example that we are going to provide here. Why? Because at this particular time both sender and receiver has to recheck and reprocess, re-verify whether the secret value itself is not sent or not, and an opponent cannot modify an encrypted message, and whether it is has generated a false message or not, it is going to check once. Okay. See, this is a message M that is going to send here. This is the hash function that we are going to apply. After that, we have performed the encryption. And again, this is the encryption. For entire message, we are going to perform the encrypted key. This is the decryption. Before going to send receiver, we have to perform the decryption for that. And this is the message. For this, it has to apply the hash function. And next, this is the source message. From the source, what is the message that we will get here? After that also, this is the original message that we, from this we are going to compare whether this is the original message or not. Okay. See, it is a confidentiality. Why you are going for the confidentiality? The concept confidentiality means confidentiality can be added to the approach of the method by encrypting the entire message, plus hash code. So more commonly the message authentication is achieved using a message authentication code. We can say that message authentication code as MAC. So we can say it is also known as a key hashed function. So message, whatever the code that we have generated by using the authentication, we can say that as a message authentication code MAC. We can already know it as a keyed hash function. Okay. Typically the message authentication code is used between the two parties. Why we are use it between the two parties? Because whenever it is used to whenever a sender is sending some data, we have to apply that message authentication code for that to provide some security. So whenever we are applying between the two parties, it is to share the secret key to authenticate the information exchanged between those parties. So a MSC function takes a input secret key as a data block and produces the hash value. See, whenever it is going to produce some hash value, the secret key that is used to authenticate the information or exchange it between the those two parties, we can say it as a message authentication code. Whenever you are used between the two parties, simply we can share a secret key to authenticate. But the information that is exchanged between the two parties is a message authentication function that is taken as an input for the secret key. And what are the data block that is going to produce the hash value? We can refer it to the message authentication code. So the what are the message authentication code that we have generated, that is transmitted with a sorted with the protected message. And if the integrity of the message needs to be checked, then the message authentication code, what for the message authentication code, what are the function that we have generated, that can be applied to the message, and the result compared with the message authentication code value. So an attacker who alters the message will be unable to alter the message authentication code value without the knowledge of the secret key. So in this particular case, an attacker who wishes to alter the message would need to know the private key. So this is the source, and this is the, if you have observed this one, this is the source and this is the destination. Most commonly this is the concept confidentiality, confidentiality comments to the picture. This is the message M. Why we have to confidentiate that particular kind of, suppose if it is a, normal message, that there is a no need that you have to provide the confidentiality. But if it's the message that is related to some higher officials or higher authorities or some large companies are going to send some confidential matters, we have to apply that confidentiality concept. For that it has to provide some message. For that it has to provide some encryption for that particular kind of message, and again it has to provide the encryption concept. After performing the encryption concept, it has to decrypt that particular kind of message, and after that it has to compare that both hash functions at the source and destination side, whether it has provided the correct message or not. At this particular time, it have to check if the integrity of the message needs to be checked or not, whether the message authentication code function can be applied to the message and the result is compared with the stored message or not. Okay. So the hash code is the encrypted using the public key encryption with sender's private key. So if you have observed this figure, it is the encrypted hash code. It is using some public key encryption with sender's private key. Okay, sender is having some private key. The receiver also has to maintain some private key to decrypt that message. It is also providing some digital signature. Why? Because only the sender have to produce the encrypted hash code. In fact, this is the essence of the digital signature technique. So whatever the code that is encrypted, we can say that one as a digital signature. It is whenever the digital signature is provided, the sender could have to produce the encrypted hash code. We have already produced the encryption. Why we have to? That is the basic message that we have to send. No, so the sender has to produce the encrypted hash code. Whatever the hash code that we have to generate, that we have generated, for that hash code, he has to provide the encryption. So it is an encrypted hash code. In fact, this is the essence of the digital signature technique. So this is the message that is sending, and this is the hash function that is applying here, and this is the encryption key. So after that, this is a message that we are going to this is the encryption key. Again, we are going to generate here digital signature that we are going to apply. So this is the entire encryption, digital signature, and the hash function. At the receiver side, it is going to reverse this concept. So whenever the confidentiality as well as the digital signature is desired, then the message plus the private key encrypted hash code can be generated using the symmetric secret key. This is a common technique for that. So if you are coming to the concepts called requirements and security, before proceeding, we have to define the two terms called, for a hash value h is equal to h of x, we can say that x is the pre-image of h. So before x is pre-image means before going to apply the hash function, it has to show this is the hash function that we are going to generate. That is the pre-image of h. So that is x at the data block whose hash function using the function h is h, because h is a many to one mapping for any given hash value h. There will in general be multiple pre-images. A collision occurs if we have x not equal to y and h of x is equal to h of y, because we are using the hash functions for the data integrity. Collisions are clearly undesirable. So here, if you have observed this table of content, then we can generally accept the requirements for a cryptographic hash functions. The first three properties are the requirements of the practical application of a hash function. The fourth property, pre-image resistant, is a one-way property. It is easy to generate a code given message, but virally impossible to generate the message given code. See, if you have observed this one, see, this is the requirement and this is the description. We have here both it can differ at the variable input size, and h can be applied to the block of data at any side. Here this is a fixed output. Here the variable has some input size. Here it is having some fixed output. Here the h produces a fixed length output. So it requirements based upon the efficiency. Here h of x is relatively easy to compute for any given x, making the both hardware and software implementations practical. So this is a pre-image resistance one-way property. For this is one-way property. Here it is for any given hash value h. It is computationally infeasible to find the y such that h of y is equal to h. So the second pre-image resistant is, it is a weak collision resistant. Here, for any given block X, it is computationally infeasible to find Y not equal to H, such that H of Y is equal to H of X. Here, this is H of Y means, we have already said in the previous slides, H of Y is the hash function that we are going to apply on Y, and H of X is the hash function that we are going to apply on X. So it is collision resistant, that is strong collision resistance. Here it is computationally infeasible to find any pair X comma Y such that H of X is equal to H of Y. Here it is pseudo randoms. Here the output of H meets standard tests for the pseudo randoms. So see, in this class we have discussed about the hash functions and the applications of the hash functions, and about the requirements and security. Okay, this is about this is the comparison between the requirement and the description. Then we will continue in the next class.